This thing you're looking at is over 5 billion years old. It survived the collision of two destroyed stars and fell to Earth in a rain of fire. And no, that's not a metaphor. The gold you wear on your finger was not born on Earth. It was not created by our planet. It never could have been. 4.5 billion years ago, Earth was hell, an ocean of molten rock, and all the gold that existed at that moment sank. Gold is hydrophilic, iron-loving. When Earth melted, iron sank toward the center, dragging gold and other precious metals with it. 98% of Earth's original gold is now in the core. At 6,000 kilometers deep, at temperatures of 5,000 degrees C, at pressures that would crush anything, that's where Earth's original gold is, and we will never touch it. So if all the gold sank to the core, where does the gold we mine today come from? To understand this, we first need to understand how stars work. The sun is a fusion reactor. It converts hydrogen into helium. It releases energy. Larger stars fuse heavier elements: carbon, oxygen, neon, magnesium, silicon, all the way up to iron. Iron is the poison of stars. Fusing iron doesn't release energy. It consumes it. When a star creates an iron core, it dies. But even in this explosive death, a normal star cannot create gold. The fusion process stops at iron. To create heavier elements, you need something far more violent. A normal star dies before it can create a single gram of the gold in your ring. So what's left after a massive star dies? A neutron star, the corpse of a star, an object so dense that a single thimbleful of its matter would weigh millions of tons. A neutron star is the size of a city, but it contains the mass of an entire sun. It is the densest matter in the universe. Now imagine two of these dead stars orbiting each other, slowly approaching, for millions of years, until they collide. This is what creates gold. When two neutron stars collide, the impact releases more energy than a supernova. They create an explosion called a kilonova. In 2017, the LIGO observatories detected the collision of two neutron stars. It was event GW1707, and for the first time, scientists observed the creation of gold in real time. Brian Metzger, the astrophysicist who predicted this years earlier, said, "It's an incredible realization that the precious metals in my wedding ring were likely forged in the vicinity of a black hole. The collision creates extreme conditions, an avalanche of neutrons, such a high density of neutrons that atomic nuclei absorb them before they have time to decay. This is the R process. Imagine a particle buffet. Atomic nuclei are in an endless line, and neutrons pass by at monstrous speed. Each nucleus swallows neutrons without stopping, inflating, becoming unstable. In milliseconds, the nuclei inflate so much that they create super-heavy elements: gold, platinum, uranium, elements a normal star could never produce. A single neutron star collision generates an amount of gold equivalent to the weight of hundreds of entire Earths. The kilonova glows for days. It changes color, from blue to red. Each color change tells us which elements are being created. The gold in your hand is nothing more than the residue of a dead star, a cosmic fossil, the ash of an unimaginable explosion. And that ash traveled across the cosmos for millions of years until it reached Earth. 4.5 billion years ago, Earth was chaos, molten magma, constant asteroid bombardment, a planet in formation. Earth was differentiating. Heavy elements sank. Light elements floated. Iron sank to form the core. Gold loves iron. It's siderophilic. When iron sank, it dragged gold with it. 98% of Earth's original gold sank with the iron to the core. It's still there, at 6,000 kilometers depth, unreachable. If we could extract all the gold trapped in the core, we could cover the entire surface of the planet with a layer of gold as thick as a 4-story building, but we will never touch it. And yet we mine gold from Earth's crust. Where did it come from? The answer is more terrifying than you imagine. That gold does not belong to the original Earth. 3.8 billion years ago, something happened. An event called the Late Heavy Bombardment. A massive rain of meteorites struck Earth. Around 200 billion tons of asteroids, each one carrying material from space, debris from kilonovae, dust from dead stars. The gold we mine today is not from original Earth. It's a later gift from space. In 2011, a team led by Matthias Wilbold from the University of Bristol analyzed ancient rocks from Greenland, the oldest rocks on Earth, older than the Late Heavy Bombardment. They measured tungsten isotopes, tungsten-182, created by the radioactive decay of hafnium, and they found something surprising. The tungsten ratio changed dramatically after the Late Heavy Bombardment. The meteorites had brought tungsten-182 and other precious metals to Earth's crust. The Late Heavy Bombardment added between 0.5% and 1% of Earth's total mass, all in the form of asteroids, all of them loaded with gold, platinum, and other precious metals. The gold from the meteorites was just a thin layer on the surface, cosmic dust, invisible to the naked eye, but enough to change human history. That cosmic dust traveled billions of light years, crossed space, survived entry into the atmosphere, fell to Earth, and now it's in your hands. The gold you hold is not from here. It's an interstellar traveler. But if the gold from the meteorites was scattered in invisible specks, how did it end up concentrated in nuggets and veins? This is where geology comes in. The gold was scattered across the crust, but Earth has its own mechanisms for concentrating it. The geological engine is water, superheated groundwater, heated to hundreds of degrees by magma. It circulates under pressure through cracks in the Earth. It dissolves the specks of gold from the rocks. When this water rises, it cools or changes pressure. The gold becomes insoluble. It crystallizes. It becomes trapped in the quartz veins that miners search for. That's what you see when you see a gold vein, the result of a geological process that took millions of years, hot water, pressure, time, and dust from dead stars. Millennia of erosion break down mountains. They transport the nuggets to rivers. There, gold prospectors find them. River gold is nothing more than the final residue of a journey that began in a collision of dead stars. Gold is the residue of a 5 billion-year cosmic journey. A neutron star is so dense that a single thimbleful of its matter weighs the same as an entire mountain. A single neutron star collision creates an amount of gold equivalent to hundreds of Earths. In the 2017 kilonova, scientists calculated that 21,500 times the mass of Earth was ejected into space as matter. Most of Earth's gold is in the core, unreachable. The gold we have on the surface is only a tiny fraction of the total. If we could extract the gold from the core, we would cover the entire surface of the Earth with a 4-meter layer of solid gold. That would be enough to turn the planet into a golden sphere. But we will never touch it. It's 6,000 kilometers deep at 5,000 degrees, under pressures that crush everything. The gold on the surface, the gold we use for jewelry, technology, and coins, all of it comes from the Late Heavy Bombardment, a rain of asteroids that occurred 3.8 billion years ago. Gold is not just a precious metal, it's a cosmic survivor, a witness to the violence of the universe. From a collision of dead stars to your hands, that is the journey of gold. Every gram of gold that exists on Earth is a fossil of a dead star. The R process is the key. R stands for rapid neutron capture. It occurs in extreme conditions with neutron densities exceeding 10^22 per cubic centimeter. In the S process, slow, nuclei have time to decay before capturing another neutron. In the R process, they capture neutrons faster than they can decay. It's like a runner eating all the neutrons in sight without stopping to breathe. The nuclei inflate, become unstable, but they keep capturing neutrons. In nuclear physics, there are magic numbers, N50, N82, N126. When a nucleus reaches these neutron numbers, it becomes more stable. They create bottlenecks in the R process. These bottlenecks cause matter to accumulate. When the R process stops, these accumulations decay into stable elements. The abundance peaks of gold, platinum, and lead are the direct result of these bottlenecks. Gold exists because a magic number of neutrons, 126, slows down the R process just enough for matter to accumulate. That matter becomes gold. Gold, platinum, and lead, all created by the same process, the same bottleneck, the same nuclear physics. Gold and platinum are cosmic twins, born together in the same neutron-star collision. At CERN, scientists are studying the R process in detail, with exotic isotopes of indium-134 and 135, with half-lives of only 121 and 97 milliseconds. We are understanding how every gold atom in the universe was created. The physics of the R process is the physics of our existence. The oldest stars in the universe, metal-poor stars, contain the chemical signatures of the R process. They are cosmic fossils. The gold in your ring was created before Earth existed, before the sun existed, before the solar system existed. Gold is a time traveler, a relic of the early universe, a fragment of an explosion that occurred billions of years ago. Gold is proof that the universe is violent and beautiful. Gold connects us to the cosmos. It reminds us that we are stardust, literally. The next time you see a piece of gold, remember, you are looking at a fragment of an extinct star that traveled across the cosmos to end up in your hands. We have used this metal as currency, as jewelry, as a symbol of wealth, but its true value is far deeper. Gold is the residue of a dead star, and so are we. The elements in our bodies were also forged in stars. Gold is not just beautiful, it's also useful. It conducts electricity without corroding. It's malleable. It's perfect for technology. And all of that is possible because of its cosmic origin. Gold connects us to the cosmos, literally. Everything we are, everything we have, everything is made of stellar debris, of stars that lived and died before we existed. Gold is fragile, but durable. It's valuable for its rarity, and its rarity comes from its violent origin. We are stardust, and gold is our connection to the universe. Gold has shaped civilizations, it has caused wars, it has built empires, all for a metal that is, literally, the residue of a dead star. Gold is not wealth, it's physics. It's astrophysics. It's proof that the universe is stranger and more beautiful than we imagine. The miner who extracts gold doesn't know he's extracting the residue of a dead star, but now you know. The next time you see a piece of gold, remember its journey, from a neutron-star collision, through space to Earth, to your hands. Gold is a survivor, like us. Gold is not just a metal, it's a story of cosmic violence, of survival, of interstellar travel. The next time you see gold, don't see wealth, see a star. Your gold ring is not from Earth, it's from space, from a collision of dead stars, from a kilonova that occurred billions of years ago. Gold traveled across the cosmos, crossed space, fell to Earth in a rain of fire, survived geology, and now it's in your hands. 5 billion years of travel to reach you. The next time you see a piece of gold jewelry, don't see an accessory. See a fragment of a dead star, a cosmic survivor. Gold is not created on Earth. It's inherited from the cosmos. Gold connects us to the stars. It reminds us where we come from. It reminds us that we are stardust. We are stardust, and gold is our proof. What other element or mineral would you like us to trace back to its origin in the universe? Let me know in the comments. Gold is not wealth, it's a star in your hand. The universe is watching. Are we paying attention?